Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter changes around us. In this session we are going to see about chemical equations which are representing different kinds of chemical changes. Chemical equation is a symbolic representation of a chemical reaction. The reactants of the reaction are represented on the left hand side of the equation and products are represented on the right hand side, isn't it? In a chemical change, first we take certain substances, they undergo certain reaction, and finally they form certain new substances. So this overall reaction is represented with chemical equation. In the chemical equation, the chemical substances which are participating in the chemical reaction are called as reactants, as we know. So in the equation, these reactants are represented on the left hand side with their symbols and formulae. And the chemical substances which are formed as a result of this reaction are called as products. These products are represented on the right hand side of the chemical equation. The representation of the reactants in an equation are in symbolic form. So the representation of reactants and products are taken in the form of their symbols and formulae. For example, if you see here, a chemical equation is represented. In this reaction, nitrogen reacting with oxygen to form nitrogen dioxide. So what we can say here now, this nitrogen and oxygen are participating in the reaction. Now we can call these two as reactants. Nitrogen and oxygen are reactants in this equation or in this reaction. And as a result of this reaction between these two, nitrogen dioxide is formed. So we can say this nitrogen dioxide as product. Okay, see, observe once, these all are represented symbolically. Nitrogen is not written in the equation, its symbol is used. In the same way, oxygen symbol and nitrogen dioxide molecular formula is used to represent it. So in this way, a chemical equation is said to be the symbolic representation of a chemical reaction. So the chemicals which are participating in the reaction, which are formed in the reaction, those all are represented with their symbols and formulae. That representation is called as chemical equation. Plus sign between the reactants represents every separates every reactant. If you observe once here, two reactants are there in this reaction. So all the reactants are separated with this plus symbol. This plus symbol separates all the reactants which are participating in the reaction. In the same way, on the right hand side also, every product is separated by plus symbol. In this reaction, only one product is there, so plus symbol is not used. If there are more than one products formed in the reaction, those also will be separated by using plus symbols. The arrow mark at the middle, if you observe, the arrow mark between the reactants and the products is used to denote the net forward reaction. So this arrow mark, say it is shown in this direction. This represents the reaction movement from this side to left hand side to right hand side. That means these chemicals are participating to form these chemicals. That is represented by this arrow mark. Okay, forward reaction is represented with arrow mark. Next, the symbol arrow mark is used between the reactants and products. Single side arrow mark is represented between the reactants and products and it is shown towards the products from the reactant side. And we observe in some chemical reactions, two-sided arrow mark symbol is used. This is used to denote the chemical reaction in both the directions, which we also call as reversible reactions. So the two-sided arrow mark is used to separate the reactants and products in the chemical equations which represent the reaction which is occurring in both the directions. Means in that reaction, reactants convert to form products And again, products may reform these reactants back. Those reactions are called reversible reactions. So to represent a reversible reaction, so in between reactants and products, we use this two-sided arrow mark. Okay? And the physical state of the chemicals are denoted in the parentheses after the symbols of the chemicals. So in a chemical equation, we can represent the physical state of the chemical substances participating and being formed by using certain symbols at beside the symbol of those or formula of those chemicals by using some symbols in the parentheses. Let us see some examples. Suppose the letter S in the parenthesis denotes the solid state of the chemicals. Let us say example here. See, a chemical equation is represented here. And if you observe here, beside the symbol of zinc, S is kept in parenthesis. This represents this substance is taken in the solid state. So in this way, the state of the chemical, the physical state of the chemicals which are used in the chemical reaction as well as the chemicals formed in the reaction can be represented by using certain symbols in the parenthesis beside those formulae. So here, S represents solid state of the chemicals taken in the reaction. And in the same way, the letter El represents the liquid state of the chemicals. For example, if we see this equation, HGO giving Hg plus O2. Here, beside Hg, they have mentioned L in the parenthesis. This represents this Hg formed in this reaction is in the liquid state. So L represents liquid state of the chemicals in the reaction. Okay, S represents solid state. Now, the letter G in the parenthesis denotes the gaseous state of the chemicals. So in certain chemical reactions, some chemicals will be in the gaseous state. So those state is represented with the symbol G in the parenthesis. Say for example, in this equation, beside hydrogen symbol, they mentioned G. This represents this hydrogen produced in this chemical reaction in the gaseous form. Okay, zinc is in the solid state and hydrogen produced in this reaction is in the gaseous state. Gaseous state is represented with G in the brackets beside the symbol of the chemical. Okay, and the letters AQ in the parenthesis denotes aqueous solution. We know what does it mean by aqueous solution. The solution in which water is a solvent is called aqueous solution. So in the above equation, if you observe, beside zinc, which is in the solid state, hydrochloric acid is taken with dissolution into water. That is represented with AQ here. This represents aqueous hydrochloric acid solution. Means a small quantity of hydrochloric acid dissolved in water. So here the solution formed is called aqueous solution. Aqua represents water. So in the hydrochloric acid solution, solvent is water. So it is represented with AQ. Okay, AQ represents aqueous solution of hydrochloric acid. And here also ZnCl2 is represented with AQ beside this formula. This also represents aqueous solution of zinc chloride. So overall we can understand here solid zinc on reacting with aqueous hydrochloric acid solution, it is forming aqueous zinc chloride solution and liberating out hydrogen gas. In this way the symbols beside the represented the symbols in the parenthesis beside the symbols and formulae of chemical substances represents their physical state. Okay, and the Greek letter delta above the arrow mark denotes the energy in the form of heat is added to the reaction. So often in certain chemical reactions on the arrow mark we observe a symbol which is called as delta, which represents it seems like a triangle. See here in this reaction, delta is shown on the arrow mark. This is pronounced as delta. This represents heat energy is supplied for this reaction to occur. Okay, heat is supplied, heat is given to this reaction for occurring. Okay, that is represented with the symbol delta. If a heat energy is utilized in a reaction to occur to form products, then a symbol delta is represented on the arrow mark to indicate that heat energy is added. In the same way, the letters H nu above the arrow mark are used to denote the energy in the form of light is added to the reaction. So in some chemical reactions, light energy will be absorbed for the production of products, for the formation of products. So in those reactions representation, in the chemical equations of those reactions, on the arrow mark, H nu is written, which indicates the absorption of light energy. One of the examples for this kind of reactions, as we know, is photosynthesis, isn't it? Photo represents light, synthesis means production. So plants, they prepare their food in the presence of light energy, with the absorption of light energy. That is why it is called photosynthesis. So in this reaction, as light energy is absorbed, here we can represent on the arrow mark with a triangle instead of writing light. Or else in often it can be represented with H nu also. Sorry, it is not H, it is not delta, it is H nu. H nu is written on the arrow mark to represent the absorption of light energy for the formation of products. Okay, in this way this all indicates certain symbolic representation of the chemical equation. Look at the following chemical equation picture, which is representing a chemical equation. Okay, in the above picture, methane and oxygen are reacting together to form carbon dioxide and water as the products. Now we can say this methane and oxygen, these two together are reactants, because these two are reacting each other to form some new substances. That is why these two, methane and oxygen, are reactants in this equation, in this reaction. At the same time, if you see on the right hand side, carbon dioxide and water are produced. Now we can say these two are products. Okay. In between these reactants and products, an arrow mark is shown. The arrow mark between the reactants and products is used to denote the forward direction of the reaction. Means these are producing these. So left hand side substances reacting together to yield or to produce these chemical substances, which are shown on the right hand side. Okay, the above reaction, one molecule of methane and two molecules of oxygen react together and form two molecules of water and one molecule of carbon dioxide. So how many molecules are participating and how many molecules of each substance are combining together to form how many molecules of each product formed also can be represented in the equation by using certain coefficients. If a number is written in front of the molecular formula of the substance, that represents number of molecules participating in the reaction to combine with other chemicals. If you observe here, one molecule of methane, because here no coefficient is there, no coefficient represents 1. So 1 won't be written. So here we can understand one molecule of methane is combined with two molecules of oxygen, because if you see in front of oxygen molecule symbol, 2 is written as a quotient. This quotient represents number of molecules of oxygen combining in the chemical reaction. So you can say one molecule of methane combined with two molecules of oxygen to form one molecule of carbon dioxide and two molecules of water as the products. Okay, this is representing number of molecules of each reactant combined and number of molecules of each product formed also we can understand from the chemical equation. Let us see one more chemical equation. See this. In the above chemical equation, N is a symbolic representation of nitrogen and 2 behind N representing number of atoms. So, while writing the molecule or formula of a chemical substance, we use some symbols, some numbers at the right hand bottom side of the symbols of those elements that represents the number of atoms of that element in the molecule. If you see here in N2, beside N we have represented a 2. This 2 represents the number of atoms of that element in the molecule. Means here N2 means there are 2 atoms of nitrogen in one molecule of nitrogen. At the same time, 2 hydrogen atoms are there in a hydrogen molecule and 3 hydrogen molecules are taken, isn't it? So 1 molecule of nitrogen combining with 3 molecules of hydrogen in this reaction. And if you see at the right hand side, 2 molecules of ammonia are formed and each molecule of ammonia contains 1 nitrogen atom and 3 hydrogen atoms. Okay, these are indicated here. So at the middle, if you observe, two-sided arrow marks are used. This indicates this reaction is reversible reaction. Means this nitrogen and hydrogen combines to form ammonia, and in the reverse way, this ammonia can yield hydrogen and nitrogen. Okay, it is said to be one of the reversible reactions. On the reaction arrow mark, it is shown here 1000 degrees Celsius. Means these reactants are heated to this temperature to form these products. And one more chemical substance is shown on the arrow mark that represents is it is one of the catalyst. Iron oxide is used as catalyst in this reaction. Catalyst makes the reaction to become speed. So it encourages the speed of the reaction. The chemical substance which makes the reaction to occur at a high speed or without involving in the chemical reaction is called catalyst. This will encourage the reaction to become faster, but it will not involve in the reaction. Such kind of substances which makes the reaction to become faster are called catalyst. So here this catalyst will be represented generally on the arrow mark. If you observe here on the arrow mark, Fe2O3 is represented. So this represents catalyst in this reaction. This makes the reaction to become faster without involving in it. Okay, these are the indications from a chemical equation. And if you see here, H is a symbolic representation, the same reaction, H is a symbolic representation of hydrogen. And 3 in front of this formula of this hydrogen representing number of molecules of hydrogen. We have studied this. Here also you can observe. In front of molecular formula of ammonia, 2 is written. This 2 represents 2 molecules of ammonia. So overall we can say in this equation, 1 molecule of nitrogen combining with 3 molecules of hydrogen to form 2 molecules of ammonia. Okay, and here some physical states are also mentioned for these reactants and products. Here beside nitrogen and hydrogen should be written in the parenthesis G. G represents these two are gases. Two gases, nitrogen and hydrogen combining together to form one more gaseous product, that is ammonia. All are gases in this equation. So the G in the parenthesis represents the physical state of those reactants and products. Okay, and at the middle, as we discussed, at the middle, two-sided arrow mark indicates the reversible reaction. So on the arrow mark, ferric oxide is one of the catalyst. This is acting as catalyst in this reaction. Okay, now let us see balancing of these chemical equations. How to balance a chemical equation? The chemical equation is obtained from the chemical experiment. Balancing of a chemical equation is defined as the number of atoms in the reactant should be equal to the number of atoms in the resulting products. What is meant by balancing equation? First of all, the chemical equation in which number of atoms of all the elements present on the left hand side is equal to the number of atoms of the all the elements on the right hand side. Number of atoms of each element on the left hand side and right hand side, if both are equal, then that equation is said to be balanced equation. If it is not balanced, if it is written only the symbolic representation of a chemical reaction, then we have to make that equation balanced so that we can understand how many molecules of each reactant participating and how many molecules or atoms of each product formed. This all we can understand only from the balanced chemical equation. So if you observe a reaction or represented with unbalanced equation, then we have to make it balanced to understand it clearly. So we have to follow certain steps for balancing of a chemical equation. Let us see what are those steps to be followed for balancing a chemical equation in the simple way. Step 1 is experimentally determine the reactants and products. So we have to determine what reactants are participating in the reaction and what chemicals or what products are formed in the reaction. First we have to determine these two. Then in the step 2, we have to write the unbalanced equation using the formulae and the symbols of the reactants and products. So after knowing the reactants and products which are participating and which are being formed in the reaction, we have to write a unbalanced equation by using the symbols and formulae of those reactants and products. And finally, we have to write the balanced equation by determining the coefficients that provide equal number of each type of atom on each side of the chemical equation. So after writing the equation, we have to use simple coefficients in front of the molecular formula of products and reactants, such that the number of atoms of each element on the both the sides of the equation will become equal. Then the equation obtained is called balanced chemical equation. Let us consider one balanced equation. See here, sulfur reacting with oxygen to form sulfur dioxide. This is one chemical reaction. So in this equation is represented with the balancing. Observe once the number of atoms of sulfur on the both the sides. Number of sulfur atoms on the left hand side is 8. And what about on the right hand side? See here, at the base it is represented 8 here. Means there are 8 atoms in one molecule of sulfur. On the right hand side, this SO2 represents sulfur dioxide molecule. In each molecule there is one sulfur atom. And there is one coefficient in front 8. This represents 8 sulfur dioxide molecules. From each molecule there is one sulfur atom. Totally 8 molecules. So 8 sulfur atoms it is indicating here. So sulfur atoms are balanced. If you observe oxygens, on the left hand side, if you observe, there are 2 oxygen atoms in one molecule of oxygen. And how many molecules are there? 8 molecules. In total, oxygen atoms on the left hand side are 16. What about on the right hand side? Each sulfur dioxide molecule has 2 oxygen atoms. And there are totally 8 molecules. So in total, the number of oxygen atoms on the right hand side also is equal to 16. So number of oxygen atoms on the both the sides is same as 16. Now all the atoms on the both the sides are being equal. Atoms of all the elements present at left and right hand side of the equation are equal. Hence we can say this equation is balanced chemical equation. Now let us consider one unbalanced equation. Observe this equation. Nitrogen and hydrogen they are combining to form ammonia. Is it balanced equation? How do we say that it is balanced or unbalanced? If the number of atoms of all the elements are equal on both the sides of the equation, then it is said to be balanced. If you observe here, the number of atoms of nitrogen on the left hand side is 2. What about on the right hand side? There is only one nitrogen atom. So it is not balanced. Even one element if it is not balanced, then the overall equation is said to be unbalanced equation. Now, what we have to do first here, balance the number of nitrogen atoms by writing 2 in front of ammonia symbol, ammonia molecular formula NH3. So if I write 2 here, what happens? See. Now, number of nitrogens on the left hand side are 2. And it became now 2 at the right hand side also. So nitrogens are balanced. Now what about hydrogens? Here 2 hydrogens are there. But on the right hand side, in the molecule 3, totally 2 molecules. Total it became 6. Now hydrogens are not balanced still. Let us make it. Balance hydrogen atoms by writing 3 in front of hydrogen symbol in the left hand side. What happens? See here. Now the balanced chemical equation is written as like this. N2 plus 3H2 gives 2NH3. If you observe once, atoms of all the elements are balanced on both the sides now. Now this equation is said to be balanced chemical equation. In this way, from the unbalanced equation, we can make it balanced equation by keeping suitable coefficients in front of the symbols and formulae of the reactants and products in the chemical equation. It can be made balanced. After that, the equation obtained is called balanced chemical equation. Okay, that's about chemical equations. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.